You can use the Pythagorean theorem to figure out how far away 2 points are if you have a picture of 2 points or 2 people with 2 points. So on number 1, there's point P and point Q, and they're asking you to figure out how far away those 2 points are on the coordinate plane. Well, you need to use Pythagorean theorem only with right triangles. That's not a right triangle, but hopefully you can visualize how to make a right triangle out of that. You could first go right and then up, and now you've got a right triangle this way. And then I'll switch colors to show you a different way. You also could have gone up first and then right. Either way you go, you can see that you have a right triangle. So I'm going to erase the red one and just use the blue one. You have to figure out how large each leg is, because currently they're not labeled, but it's pretty easy to count. If you look at the bottom, it's counting by 1. So this is 1, 2, 3 units wide, and it is 1, 2, 3, 4 units tall. So the 2 legs of this triangle are 3 and 4. So the Pythagorean theorem is a squared plus b squared equals c squared. One of the legs is 3, one of the legs is 4, and to figure out how far away P is from Q, well, that's the hypotenuse of this triangle. So that's what we're trying to figure out. So it will remain C. So just like last week, you're going to square each of these numbers. So 3 times 3 is 9. 4 times 4 is 16. That will equal C squared. If I add these two numbers together, I get 25. Last step, remember, is to take the square root of each side. So the square root of 25 is 5, or 5 times 5 is 25. So the distance between P and Q is 5. Number 4 is the same concept, except there are decimals. That means that in this particular problem, you need to round the numbers first, because that's what the directions ask you to do. That will make your problem a little bit easier to do. So 2.2 is very close to 2, and 3.7 is pretty much 4. So these coordinates are now 2 and 4. And for Q, I have a 10.3. Well, that's closer to 10 than it is 11. And 9.8 is very close to 10. So the coordinates for Q are now 10 and 10. I'm going to still make a right triangle here by going to the right and going up. And now I have to figure out how long and how tall this triangle is by using the new coordinates, because I can't just count like I did in the first example, because they are not where they should be. So my original X, which is the one that's going across, so I have a 2 down at the bottom, and it goes all the way to 10. And so 2 and 10 are 8 units apart. So that's going to be one of my legs. And then if I look at my other numbers, it goes from 4 to 10 on the y-axis, which is going up. And from 4 to 10 would be 6 units. So my other leg is 6. So if I use the Pythagorean theorem, a squared plus b squared equals c squared, one of my legs is 6, the other leg is 8. And again, I'm trying to find out the distance between P and Q, which is really my friends at a concert. I'm at one point, my friends are at the other, and I need to get to them. So 6 times 6 is 36. 8 times 8 is 64. And we are trying to figure out the hypotenuse, or C squared. If I add these two together, I get 100. And my last step, if I take the square root, you could use your calculator, or hopefully you know that 10 times 10 is 100. So my answer, rounded, is 10. The last example that we're going to do, you've got 2 problems that look like this. This is number 6 in your assignment. And they're asking you to determine whether the triangle that's shown is isosceles, scalene, or equilateral. Well, first of all, that triangle is not a right triangle. That's why they're asking you, is it isosceles, scalene, or equilateral, which means, do you have any equal sides? And we are going to have to figure this out by using the Pythagorean theorem a little bit. But let's decide what those words mean. So if you have forgotten, equilateral means all sides equal. So all three of the sides are equal. Isosceles means two sides are equal. And scaling means no sides are equal. So we have to figure out if any of these sides are equal to each other. So to do that, we're going to need to make a right triangle. And if you look, I can just cut this right down the middle, and it will form two right triangles. All I need to do is count one of them to figure out if this is isosceles, scaling, or equilateral. So I'm going to count 1, 2, 3. From the middle of the triangle to the edge R, it's 3 units wide. And if I count up, it's 1, 2, 3 units tall as well. So that means so far it's not going to be scaling because at least 2 of the sides are equal. It could be that 2 sides are equal. It could be all the sides are equal. So let's use the Pythagorean theorem to figure out how long it is from Q to R. So one side is 3, the other side is 3. So 3 times 3 is 9. 3 times 3 is 9 again. And if I add these, I get 18. If I take the square root, I'm looking for that side to be 3 for all the sides to be equal. Well, 3 times 3 is not 18. So I know that that is going to be bigger than 3. So all the sides are not equal. That means 2 sides are equal. So from the drop-down menu, you would click isosceles. I can't click it right now because I'm using my pen feature, but you would pick isosceles from the drop-down menu. If none of the sides were equal, you would pick scaling, and if all of them are equal, you would have picked equilateral. I have a Zoom session today. Please feel free to join it if you want to see other people or you need help. I would love to see you. Bye-bye.